Okay, so today we are going to learn about polynomials and multiplication of polynomials. There are various methods to multiply polynomials, and we will discuss the tile method today. First, before proceeding, what procedure is, we would like to touch base upon what polynomials are. So polynomials, as the name says, it's polynomials. That means many terms. So what are these terms? They are just composed of two parts, which are number part, which are the constants that can be numbers or that can be positive or negative numbers. So basically numbers. It could be fractional, anything. There are no conditions to that. They just have to be real. The second part of the term is the variable part, which, as the name says, is variable. Hence, we don't know. Now, these variables can be one variable or multiple variables, two and so on. So, depending on that, we call it univariable or multivariable. Generally, we deal with the univariable ones. So, the convention is that we write the number part followed by the variable part. By mathematical rules, there is a multiplication in between these two, but we to avoid redundancy, we don't write that part. We just write it like this. For example, 6y, right? So 6 is the number part and y is the variable part because we don't know the value of y. So this is one variable. So if I say 6xy, now both x and y are the variable parts, whereas 6 is still the number part. So now how many variables are there? There are two variables, right? Similarly, 6x square. Now the square is the exponent. The total thing is the variable part, but the power, the highest power is 2. So now for a polynomial to be polynomial or a term to be polynomial, the exponent has to be greater than or equal to 0. Right? Let's say x to the power x to the power let's say prime. So a prime has to be greater than or equal to 0. If it's less than 0, it does not qualify as a polynomial. So now, depending on the number of terms, we can define them as monomial, including one term, binomial, including two terms, and trinomial. So if we give you an example, 6x square plus 2x, then 6x square plus 2x plus 3. Now, what is 3? Is that a term? Because it is a term, because the x, the variable part here, has the exponent of 0. So all the constants are also a term which has the variable part, but their exponent is 0. Now, to understand the tile method, there are different conventions out there. The one that I like the most is to make the tiles corresponding to the exponent of the variable. So for now, we will deal only with the one variable multiplications. Okay. So let's say you have this 1 square, right? And so this means this will depict x to the power 1 because there is 1 square. If we make two squares like this, this will depict x square, right? And similarly, if we keep going, this will depict x cube, right? Depending on the number of exponents, right? So how will we represent x0 or the constant term? We can represent that by a circle, okay, because 0. So now when we are doing the multiplication, we need to take care of the positive and negative signs as well. So what we will do is we need to define them separately. So how do we define them separately? We can just use some convention. So what I use is I just shade them. Okay, so if I shade them, that is my way of saying it's negative, right? Negative x squared, negative x cubed, and similarly for negative numbers. Okay, so this is the convention that we are going to be following. Next, let's say we are doing an example. So first, we can multiply it with a constant. We can multiply monomial with monomial, monomial with binomial, or vice versa, then binomial with binomial, and so on, right? We can keep on increasing. So this is polynomial. It can be anything, monomial with constant or binomial, and so on. So today, to give you an idea, we'll do the binomial with binomial. Let's take an example. 3x squared minus 2x times 4x minus 4. Okay, so let's say this is our multiplication problem. So first, what we need to do is we need to make the corresponding tiles. So I'll give you one example and the rest I will just populate. So there are x squared. So for x squared, we have a double tile, right? And how many of these are there? 3, right? So we'll make 3 of those. So this stack right here, this represents 3x squares, right? Similarly, how do we represent x? Like this, but it's a minus x, right? So how do we represent minus x? By shading it. And how many of these are there? 2. Right? So there, this stack now represents minus 2x. Similarly, if we make for the other ones, it would look something like this. Yeah, so it would look something like this. So now 4x minus 4. So before we proceed, I would like to revise a rule which says multiplying a negative number with negative number gives you a positive number. Multiplying with a positive number with a positive number gives you also positive number. But when we have a combination of opposite signs, we will always have negative. Okay, so we have to remind ourselves of this rule. Next step, what we do is we will make a grid. There is no rule which one will go where, but I tend to use the one which has less values to be on top, but it doesn't matter. You can do both depending on the space, right? So let's say we are doing 3x squared minus 2x on this side, and this side, and 4x minus 4 on this side. So I'll just populate it, and this is how it will look like this, right? So now what do? We multiply correspondingly all the elements. So multiplication is nothing. We just add up the boxes. Okay. So 1 box and 2 box. So how many box? 3 boxes, right? Similarly here. Similarly here. So we multiply each element with everything. So this will be corresponding to this one row. And similarly we do with this, we do with this, we do with this, right? So I will just show how it looks like for the first combination. So this is how it will look like for the first combination, where we have 2 boxes and 1 box correspondingly, right? Now I'm going to populate similarly all the other combinations. So as you see, a positive and a negative one will make 2 negative boxes, right? So this is how it looks like after writing all of them. If you put a special notice here, for the negative ones, we get 1 box, but it is positive, that is unshaded, right? So now we just club all the similar types together. I used color coding for that, but you just need to figure out which ones are the similar ones. So these are same, all these are same, and these are same, right? So we just manually count them, and you will find out that these are what? X cube, positive, right? And how many of these are there? 12, right? And for this one, we have, this is negative x square. And how many of these are there? 8 here and 12 here. So 20 of these. And similarly, for the last one, we have, this is positive x, and how many of these are there? 8. So this is just counting part. So we have x cube, we have negative x square, some negative x square, we have to fill in the counting numbers, and x. Count them and we substitute how many of these are there. So this is our final answer for the multiplication of the 2 binomials that we took. So similarly, this can be extended to any kind of multiplications of polynomials. Thank you.